Hi, welcome to Rangle.io's Think in Angular 2. I'm Michael, and I'm here with Varun and Evan, and we're going to be talking about all things Angular 2. There's a number of new features that Angular 2 brings and takes advantage of. It's taking heavy advantage of TypeScript and Decorators, uses a component model. Observables are heavily used in Angular 2. Dependency Injection, of course, is back in Angular 2. It was in Angular 1. There's a new routing model, a number of new change detection strategies, immutability, and really great form support. So we're going to start off by talking about TypeScript and ECMAScript 6 and how they impact Angular 2. So ECMAScript 6 is the upcoming version of TypeScript, and it's a superset of ECMAScript 5. So everything in the JavaScript that you know and love is present in ECMAScript 6, and TypeScript is a superset of ECMAScript 6, and everything in ECMAScript 6 and 5 is also in TypeScript. Both ECMAScript 6 and TypeScript currently have to be transpiled to ES5 to run in most browsers. This can be done using the TypeScript compiler, Babel, Webpack, and other tools. And TypeScript can also understand regular JavaScript libraries that you might be used to working with through definition files. So one of the first features people notice about ECMAScript 6 and TypeScript is the presence of classes. Classes will be familiar to other people from other object-oriented programming languages. In JavaScript, to some, they're a welcome addition because they provide a lot of helpful syntax around JavaScript's prototype model. So one of the new introductions that classes bring for people who aren't used to classes in JavaScript is the idea of constructor method. So every class has an optional constructor method that runs when the class is first instantiated. For ECMAScript 5 people, this can be thought of in similar terms to, well, the functions that were classes in those days. And then regular methods, you can actually use a shorter notation where you don't have to worry about saying, function.prototype.this. You can actually just say list toppings within a class. So it is quite nice. Now, one of the things to keep in mind when working with classes in ECMAScript 6 and in TypeScript is that this still functions the same way that it did in ECMAScript 5. So a lot of old-time JavaScript programmers will be very familiar with being aware of the fact that this is context sensitive and it depends on who's calling the function. This can be especially troublesome for people when they're dealing with higher order functions or functions that have been somehow nested into a method. So in this case, we have a simple example of this which will actually work as we would expect it to work. This refers, of course, to the instance of class in this case. This.formatToppings invokes the formatTopping method, and it's actually using the format list we expect. Now, if we had wrapped that up into a function, what we would see is not the list that we were expecting. So one of the things ECMAScript 6 has brought to the table to help ease this for developers from classical languages is the idea of arrow functions. Arrow functions are really cool. They don't bind this, so you can call this and it will refer to the this in your outer scope, which helps write higher order functions that do the things you expect. And arrow functions also provide a much shorter syntax for declaring functions that can be useful for things beyond just getting around this. TypeScript brings a whole bunch of features into the mix, and the Angular 2 team makes heavy use of these features. TypeScript is, again, just a superset of ECMAScript 6 and 5, so you can actually, for the most part, write plain old JavaScript and have TypeScript work with it. Under the hood, of course, traditional JavaScript always had types. They just were pretty hidden, and TypeScript brings them out to the surface, as well as adding types for enumerable concepts, any and void. Void is more or less like when a function returns undefined. It's void, just like in other imperative languages. And TypeScript brings an interface to the mix. Interface lets you define abstract types and define things like function signatures, which are really helpful for callbacks and other things like that. And classes, of course, also define types. One of the really nice features about TypeScript is that you don't have to rely on the actual names of interfaces or classes to worry about types. I mean, if it walks like a duck, it is a duck in TypeScript. Types with the same shape are compatible. And so what we mean by the same shape is that if you look at an example like this, there's a very simple user interface that just describes a simple object that's going to have a name property, which is a string. And below that, we've defined a class, which is called NotAUser. So very different names. And again, it just has a constructor that takes a public property name and assigns it as a string. One nice thing to note here is the shorthand that TypeScript lets you use. What this constructor line is actually doing is saying that it has a local property called name, and it's a string, and it's going to be assigned when you run the constructor. So just below that, we actually let u, being a user type, equal a very simple user type like we've defined above. It's just a simple JavaScript object with the name Pat. And then below that, we're able, without any type warnings, to assign a new not a user to it. So just the fact that these two different objects come from different sources with different names, but they share the same shape. So they're actually type compatible. And that's really nice when you're working with TypeScript. And that's also really nice if you come from other languages that make it very hard to work with types and very verbose to work with types. Decorators are a feature the Angular 2 team was very excited to work with. They've brought them into TypeScript. We'll see decorators throughout Angular. They can be a little bit intimidating at first, but there's really nothing to worry about. Decorators are just functions that operate on a target. In this case, by target, we typically mean a class declaration, a method, a class property, or a parameter to a method. And we see those heavily used in Angular. Now, decorators are invoked with a leading @ sign, and we see them in Angular like in @component. And in Angular 2, decorators are always going to use trailing brackets. So we'll have like an @inject with the brackets. And it's really important to not follow decorators with a semicolon, or else you can run into some hard to diagnose problems. So up next, Varun's going to talk to you about components.
So in Angular 1.5, we were introduced to this idea of a component, and Angular 2 just kind of builds upon that. Components are essentially reusable UI building blocks that you can use to construct your application, which essentially means that a component consists of a view which is defined in a template and some kind of logic that's defined inside a class. So let's look at a very basic component here. We start off with a class, in this case the hello component class. This class has an internal property called name. In the constructor, we set this name to be world. And then to turn this class into a component, we use the @component decorator from Angular 2. Now, this decorator accepts several values. The most important ones that we care about right now are the selector and the template. So the selector is essentially the kind of ID that you can use in your markup to actually use this component. And then the template is just the raw markup that will be rendered out when this component is rendered. So at the bottom, you can see NGC hello component tags that are used to render out this component inside your HTML. So this idea of components is really important in Angular 2 because your entire app is essentially going to be a tree of components. So this is just an example of a to-do app that's built out with components. So at the root, you have the to-do app component. Now this to-do app component consists of a to-do list component and a to-do form component. And then the to-do list component is made up of several to-do items, to-do item components, depending on how many items you actually have in the list. So now, once we've seen how to create a component, the next thing we need to worry about is passing data into this component, because this is a tree structure, so you need to pass data down from the root component into its child components. So in order to do that, what we use is the inputs property that's available to us on the component decorator. The inputs property is essentially accepts an array with a list of strings. These strings then get converted into attributes that can be used to pass data into the component. So once we define, in this case, an input called name for our component, in our markup, we can use it similar to what you might be used to in Angular 1 with directives. So you can create an attribute called name and pass in some data. The important thing to note here is, by default, if you pass some data into the name attribute, this data is considered to be a raw string. However, if you wrap this attribute in square brackets, now suddenly this turns into data binding. And this attribute can be bound to variables in parent scope. So in this case, in the second case where name is wrapped in square brackets, this name that's within quotes is actually a variable defined in the parent scope. And also we can respond to events within a component. So we can start off by looking at this counter example. So in this case, we start off with num, which is an internal property on counter, and set it to 0. And then we define an internal method to this class called increment. And every time increment is fired, you simply add 1 to this.num. So in order to attach this increment event to a button, what we do is set it to the click attribute for that button. But you'll notice that this looks slightly weird. The click attribute is actually wrapped in ellipses. And these ellipses are really important. This is the Angular 2 syntax for binding to events. Just like square brackets let you bind to data, ellipses let you bind to events. So now when you click on increment, every time the user clicks on increment, number will be iterated, will be added by 1. So once we have events hooked up within a component, there's a very good chance that you also want to propagate these events back up to its parent. So the way we do that is by using this idea of outputs. So similar to inputs, we can define outputs for a component, and again, it accepts an array with a bunch of strings. And then in order to create an event, to create this output, we need to start off by importing event emitter from Angular, and that's available on Angular 2 core. And then once we have this event emitter class available to us, what we can do is create a property onto our component. In our case, we're calling it result, and create a new event emitter instance and assign it to result. So now, every time we want to emit some data from within this component, we can call this.result.emit and pass in the data that we would actually like to emit out of this component. So in this case, it's similar to the previous example. So you pass in you have a number within this component, and every time the user clicks the button, that number increments by 1. And all we're doing now is propagating that new number out of this component. And you can bind to this emitted event in your parent scope. So in this case, when we use the counter component in another component, you can wrap the result attribute with ellipsis, and then you can simply bind to that event by passing in a callback. So in this case, every time this.result.emit is fired within the counter component, its parent, which assigned this onChange function, that onChange function will fire at the same time. So then you can see how this kind of links up into two-way data binding. So two-way data binding in Angular 2 is essentially a combination of both input and output bindings attached to a single ngModel directive. So when we say ngModel equals to name and wrap ngModel in both ellipses and square brackets, now suddenly this name is both data binding from the parent component into the child component, but also an event binding from the child component into the parent component. So one of the things that you can use within components, and you're likely to use a lot, is structural directives. So structural directives are essentially just utilities within Angular that help you change the layout by adding or removing DOM elements. So for example, things like ngIf, ngFor, and ngSwitch. And these might look very familiar to you because they're similar to what we had in Angular 1. The big difference being that ngRepeat has now been replaced by ngFor. And then the syntax is slightly different. So you'll notice this asterisk syntax, which allows us to define these directives in a very succinct way. You can choose not to use the asterisk syntax, and then you have to rely on a more verbose template syntax, but I'm not going to delve into that right now. Another important concept with components is projection. Now, projection is very similar to the idea of transclude in Angular 1. The only difference being that projection is actually enabled by default. So all components have inherently are allowed to project within themselves. All you have to do is add a ngContent directive within its template. And then when you go and use this component, and this, in our case, if we use a child component in our template and put some content within the tags for the child component, that content will be moved and replace this ngContent directive. So when we looked at the outputs coming out of a component, we talked about using an event emitter. Now, an event emitter is essentially an observable, and observables are a very essential part of Angular 2. A lot of internal services, such as the HTTP service, return observables to us. So observables are essentially a continuous channel of communication where you can pass multiple values of data from the creator of the observable to anything that's subscribed to that observable. And most importantly, an observable is essentially using the same pattern as an array. So you can use array-like operations, things like map, filter, merge, and you can kind of apply these operations onto the observable to essentially make your life easier. So I have a link in here for RxMarbles, which is a pretty awesome resource when you're first starting off with observables. It helps you understand what's going on. So here I have a marble diagram for the filter function. In the top, you can see the marble timeline for the observable. So you have things like 2, 30, 22, 5, 60, and 1. And these are data snapshots that we are passing into the observable. And then when we apply a filter operation onto it, we can essentially filter out the events that we care about. So if we subscribe to this observable after applying a filter, we only get updates that are successfully passed through the filter, and we ignore everything else that was being put into the observable. So let's look at how you would create an observable. We start off by importing observable from RxJS. And that might seem weird. Why are we importing something from RxJS and not Angular? The reason for that is Angular does not implement observables themselves. They rely on RxJS to provide observables. So once you have them imported, you can create a new observable by calling new observable. And this accepts a callback, which returns an observer argument to you. And this observer is essentially where all the magic happens. So when you call observer.next, and pass in some data into that function call, that's the data that's being pushed onto this observable. So when I call next 42, next 43, and then complete, essentially this observable will have 2 data events, so one with 42, one with 43, and then finally we call complete to fulfill this observable. And then in order to subscribe to this observable, so this.data is the observable that we created, we can call this.data.subscribe. And the subscribe method accepts 3 arguments. The first one is essentially the success callback, which is fired every time the observer calls .next. The error callback, which is fired if the observer errors out for some reason. And the last one is the complete callback, which fires when observer.complete is called. So once you have the observer created, there's a good chance that you might also want to dispose of this observer. So you can tie into the lifecycle methods for a component, so things like ng-on-destroy, and call the subscription.unsubscribe method. So every time you subscribe to an observable, so this.data.subscribe, that returns the unsubscribe method to you. And by default, this is just the default unsubscribe method that comes with an observable. But you can also add custom methods to this unsubscribe method. The way you do that is when you define your observable, the last thing you need to return from that is the on-unsubscribe method. So if you're setting timeouts within that observable, you have a chance to clear that timeout using this unsubscribe. So when you call subscription.unsubscribe, not only does it dispose of the observable, but it also fires this unsubscribe method so that anything that needs to be cleaned up within the observable, you have a chance to do that. So there's an important thing to note, difference between promises and observables. The most important one is that observables can be cancelled. Also, with observables, you can define both the setup and teardown aspects of the synchronous behavior. And of course, you can retry observables by using the retry and retry when operations. So finally, I wanted to show an example of using some built-in observables. So like I said, HTTP service in Angular 2 now returns an observable instead of a promise. So we can start off by calling http.get, and all we're doing here in this example is fetching some kind of JSON. And then you can call the .map operation on it, and this allows you to grab the response that's coming from the HTTP request and convert it to a JavaScript object by calling the .json method. And then you can filter on this to grab whatever data you need based on the actual data that's being generated by the map call. So in this case, we're only going to care about results that have a person whose age is over 18. And then finally, when we subscribe to this observable, we get this data. We get the data coming in from this request, and then we can assign it to our class or do whatever we want to do with this. So the important thing to note here is this subscribe function is only going to fire if this filter returns true. If the HTTP request you make does not have a person with age greater than 18, this subscription never actually fires. So which is pretty nice to have that control. And that's pretty much it for observables. I'll switch back to Michael now. We'll talk about dependency injection.
All right, thanks, Varun. So dependency injection is basically a simple means of organizing all your bits of code that actually create stuff and centralizing it in your framework so that it can be distributed to your other components and services, and then they don't have to worry about implementation details and other specifics of construction. Dependency injection was a core feature in Angular 1.x, and that has not changed at all in Angular 2. One of the main changes, though, is that Angular 2 has simplified Angular 1's dependency injection further. Angular 1 had a whole bunch of different components that could be injected and whatnot, but now in Angular 2, everything is just a TypeScript class that has been marked up with an @injectable decorator. So it's much easier to create things, to inject them without actually tying them to your framework too much. And Angular 2's dependency injection system also allows for multiple namespaces and some other advanced features that they couldn't get into Angular 1. So let's take a look at getting started with dependency injection. So this is a very simple application bootstrap in Angular 2. We've imported our bootstrap, our injectable decorator, and a hypothetical app component. And we've defined a little class here called hamburger, and it's got the injectable decorator on top of it. And at the very bottom, we've bootstrapped our main app component as the root of our application, and then we have provided it with the hamburger class. And this lets Angular know how to build hamburgers. But how does Angular 2 really know how to build hamburgers? Well, it's assuming that they're all classes, and we'll touch a little bit more on that in a few slides. But first, I'm actually wondering, how about the bun and the patty and the toppings? I mean, how did hamburger get those? And really, it's just that the example was abbreviated. So let's take a look at a full example here. We've just built out the example from before a little bit more, still importing our bootstrap and our injectable in our app. But here you can actually see the stubs for the patty class and the bun class and the toppings. And again, they all have the @injectable with the brackets and no semicolons before them, and they're all injected into the root injector of the application at the bottom there. So hamburger, patty, bun, and toppings. And that's how one would get them in. Angular 2 then knows how to build them because they're all classes, and it can give them to the rest of your class. So let's take a second and talk about @injectable. @injectable is a TypeScript decorator that lets Angular 2 know that dependencies can be injected in the first place. It's not strictly mandatory. Any class that has been marked up will technically be able to be injected by Angular, but add_injectable has much cleaner semantics. So if you're coming along reading, you can see add_injectable and know exactly what that code means. It's very clear. It's also very important, as well as not putting a semicolon after injectable, to always include those brackets. If you don't have the brackets at the end, it doesn't work as expected. Now, there's another decorator called @inject. @inject is for when you need to actually manually inject something. Now, normally, if you're working with TypeScript in Angular 2, types actually fill Angular in on exactly what it needs to do with injection. So we see some of that Angular 1 magic working its way back into Angular 2. @inject is for certain cases where TypeScript can't reason about the class that it needs to inject. And typically this might be if you need to inject a primitive like a string or a number, or some sort of third-party library that might not be typed as well as it could be. And so @inject takes as its parameter its first parameter a string or a class name, and then you just define your property, and that's it. Away you go. So let's take a quick look at using the manual @inject syntax. And again, this is, if you're using TypeScript, you don't really have to worry about this too much. So here in a hypothetical app, we sort of build out our component, and as we go down into the actual constructor, we can see one of those @inject decorators there. And it's asking for a class named hamburger, and it's assigning it to a parameter named h, and then in turn we assign that into the bun type. And we could have used some shorter hand for that, but this demonstrates @inject. And we talked a little bit earlier about how Angular assumes that everything that is an injectable is a class. Well, it turns out that it doesn't have to. It can do more than that, and it does so with a provider method by providing @injectables. Provide lets you define a string or a class and then describe to Angular how to actually build that. So in this example here, we have imported our app component, hamburger service, Angular 2's bootstrap, and of course Angular 2's provide method. And of course we bootstrap our app like normal, and then in our array of providers, we actually specify provide. So before we just use the class shorthand, this is the long form of how you would provide a class. And so first parameter is the name of the class, and then we tell Angular, hey, use this class hamburger. But of course, DI can do more than just classes in Angular 2. We can do, in this case, a factory function, where in this case, we've used that longhand provide method, and this time we're giving it a string called R random, so we can use @inject with R random elsewhere in our code now, and it'll provide this random factory to consumers. And now Evan's going to take this opportunity to talk to you about routing.
Hi, so in Angular 2, the team has done a fairly large overhaul of the routing system and has now introduced what is called the component router. This router should also be working in Angular 1.5, I believe is the plan, and this is meant to be a bit of a bridge between Angular 1 and Angular 2. With the component routing, there are three primary parts to the configuration and the setup of the router. There is the route config decorator, the router outlet directive, and the router link directive, and we'll be going over how to use these over the next few slides. So some of the features that are available in the component router is it also allows for child routes. So for each route that you define, a component can have their own child routes. There's also support for lazy loading of routes and modules, and also having kind of auxiliary routes and named routing views. The first part of getting started with the routing in Angular 2 is providing the route config for a component. So the route config is a decorator that you can import from the Angular 2/router, and it is expecting an array of objects that are the router definition objects. Some of the properties that you can provide is the path that will be used for the component, then either as or name, which is the name that you'll refer to, that you'll use to refer to the component throughout the application. There is a optional use as default, so if you land on this component and there's no routing that will match, it will default to this route. Then also you also need to either specify a component or a loader if doing a async route, where the component is the actual component that you want to have this route load in your router outlet. So in this example, we simply have two components being routed, and to kind of tell Angular where we want to place the content of the router, you have to use the router outlet directive. So with this, each component can have one unnamed router outlet. If you need to have more, that is for the auxiliary routes, which we will not be covering today, but you'd have to specify a name, and the configuration of that is slightly different. But for the basic routing scenario, assume that you only have one outlet, and this is where, when your application matches this route, it will place the content of a component there. And the next part to using the routing is the router link directive. This is what allows you to form up links to the various routes and child routes within your application. To use this directive, use the square brackets around router link, and then the value that you provided is the router domain specific language, or DSL. If you're reading the Angular docs, is what it will refer to it as. And what this is expecting is an array where the first part is the path to the component, and if you're passing in parameters, there would be a second object in the array showing the parameters that you want to pass in. We'll be discussing that a bit more in depth when we talk about routing parameters. And also, one reason why you'd want to say the router link instead of say just manually forming your href link is because with this you're able to refer to the parts of your application by the name that you specified in the router definition, so you don't have to keep track of what all the paths are actually going to be in your templates. And it also ensures that if you update your router definition, all of your links will kind of be in sync and updated correctly, where if you're using your own href, you'll have to kind of do that on your own, which makes for a very brittle and difficult to maintain application. One thing to keep in mind with the router link is the prefixes that you have in front of your links. In the previous example, you saw that it was just /component1. This means that it will look for that route in the root of your application. For more complex routing needs, you might need to do the router lookup from either the current component's child routes, so that would be a // or if you need to look at the parent's routes to see where you want to navigate to, it would be // and this is just kind of the example all in one now, where we're using the @ component. The directives that you have to import for Angular to understand how to use the router outlet and router link is you need to provide the router directives into the component, and then at the bottom we just have the full routing config. So as you click on the links above, it would place the content into the router outlet that is inside of the div with the black border. Up next, we will be talking about creating child routes. So the key thing to keep in mind when creating your child routes is the path in your router definition object needs to end with a ... So in this example here, we have our component 1 that is being our default route. There's no ... So this means that there are no child routes here. On the next route that we're defining below, you see /child route /... and also the component that we want to use to handle this routing. So what this does is when Angular sees a route that begins with /child route, it will then look at the router definition and the child route object to figure out where to go next. So when you're creating a child component with router routing, one thing that you need to keep in mind is that you need to have what Angular considers to be a terminal route, which is a route that it will default to if it can't find anything else. The ways that you can do this is by having a use as default, or either have a redirect to. If a route like this is not provided, then Angular will complain that it can't understand the routing information that you have provided. Another thing to keep in mind is the parent routes will have the prefix of, in this case, the child route in the path automatically applied. So when you're doing your route configuration here, you don't need to keep track of what the path was beforehand. This allows you to put the component anywhere you want to in the tree and not have to be thinking about how do I have to form up the earlier parts of this route. And with this, child routes can also have their own components that have their own child routes also, so you can have this like deeply nested component-based routing structure. Then one of the last things that I want to touch on before moving on is using the route parameters. Having parameters in your routes is fairly important because this is what, say if you want to pass in an ID to load, a user record, or having a message being passed along. So with the routing, to that you have to use a colon, then the parameter name that you want in your path definition. So you can see in our route config done here, we have message component / message. This means that when Angular is matching a route that is / message component, it will treat the part after that as being the message parameter. So how this affects the router link DSL is you can see we have the message component, then the second element in the array is an object that will contain the parameters that we want to pass into the message, into the message a component. And as an example, to kind of show how to access the route parameters. Sorry for the mishap on the slide, but basically you will inject the route params into your component, and then have this .message equals route params.getMessage, and this is how you will access the parameters within the component. And then up next is change detection.
All right, thanks, Evan. So change detection, as we sort of started to get a preview of in the route section there, is a core feature to Angular. Not just Angular, but most frameworks and most applications. I mean, responding to changes is very important, and that's how we get information from users and databases and all that wonderful stuff. So in Angular 1, it really automated change detection, and it was a great feature. But Angular 1's bindings were susceptible to circular update problems. And there was also only one method of change detection, and that was dirty checking. So dirty checking was the process of watching everything that you expect to change and then responding when it eventually did change. And Angular 1's change detection had some issues, especially with when a lot of items were being watched. So when you got up to about the 2,000 mark, or even less on mobile, you could start to experience some suboptimal performance. And this is an example of an Angular 1 component tree and an Angular 2 component tree. So in Angular 1, you can see it's really hard to reason about how your app is going to update. You might have a root component updating a child or a sibling component, which in turn updates the root again, and so on. And it could take ages for your app to actually stabilize its updates. And you could also run into these situations where you had, $digest loop just spinning or spitting out errors that you weren't really expecting, and those could be annoying. In Angular 2, they've smoothed this out. So Angular 2's change detection is always going to start from your root component and traverse the tree downwards and give you very consistent, easy to reason about change detection. It's really important to note that and to emphasize that Angular 2's data bindings are one-way data bindings, and this actually even includes their two-way data bindings. The two-way data bindings are just cleverly arranged to look like two-way data bindings, but they're really just one-way data bindings. And in Angular 2, we've seen from the alpha and we've seen in the beta that change detection is scaling really, really nicely. And they've provided a couple other methods of change detection for us. So this is how you would actually specify a change detection method in a component if you wanted. So this example has cut out all of the cruft of setting up a component. And we see here in our decorator change detection, and this change detection strategy is one of those TypeScript enums, so change detection strategy.default, and that's, you could use one of the other elements on there to define something else. The default is going to run through your component tree and check and see if all of your things have changed. As I'm getting at, Angular 2 is providing several different change detection strategies. We've got default observer, checked once, check always, detached, and on push. On push is really interesting because it is an immutable form of change detection. And I've got an example here where, where we can see how immutable change detection actually works. So this example consists of two components. There's one component here, which is sort of the main component, and it's going to modify things in such a way that the immutable data structure Angular is expecting becomes out of sync. And then down here we actually have our very simple component where we've actually explicitly told it use the change detection strategy on push. So that's the exact same thing we saw before, just in an actual working plunker. And so up here we see that when we actually click on these buttons, we're either going to swap in a brand new actor, which is a new object, and that'll trigger a change, or we're going to change the parameters directly, and that's not going to trigger a change because Angular's been told only to look for it on push changes, which it's not going to get. So if I change actor properties, you can see here nothing is happening. Angular does not know to update, and that thing is actually firing. But if I hit change actor object, there we go, it changes to Bruce Willis as expected, and again, nothing else happens when I click that. So back to the slides here, we're going to talk a little bit more about immutability. And Evan's going to take over for that.
Hi. So kind of, and this ties in a bit with the on-push change detection. So immutability is basically a design pattern where something can't be changed or modified after it has been created. So if you have a actor object and you want to change the actor's name, you can't just do like actor.name equals new name. You have to kind of create a new actor with that new name. And the reasoning behind this is that it helps kind of manage your application state and also being able to ensure that the references to the objects that you have in your application are kind of what you think they are, and being able to control the changes in your application. ES6 has a few new features that allow for an easier implementation of immutable design patterns by having a few kind of quick ways to create shallow copies of objects and arrays. But in practicality, it is better to use a library like ImmutableJS, which allows us to work with immutable data structures in an easier way, and also ensuring that there is immutability within your application. So some of the cases for immutability is basically managing your application state is difficult. When you have many parts of your application all holding reference to the same object and then modifying that object in ways that you don't always control, or potentially even replacing that whole object, you're going to have a scenario where your application state starts to fall out of sync with each other and changes aren't propagating through your system how you would expect. Immutability attempts to solve this by controlling how and where the state can be modified. At times in smaller applications, this can be really easy to manage and understand to see where things are coming from. But as your application grows, you're dealing with asynchronous flows and observables and many things potentially touching on the same data. This can lead you into a spot where it can be very hard to understand what happened to your application. How did your application state get to where it is? And also with the on-push change detection in Angular, where it will only trigger the change detection if the reference to the object has changed. This can have some interesting performance implications on your application if used correctly. So, just as a very basic example, this is kind of showing how mutating an object at times can lead to things that you don't always expect. In this case, we have movie 1 assigning it to movie 2 and setting the episode to 8. In this example, you can kind of see exactly how movie 1 got modified because because movie 2 is now a reference to movie 1, not a copy of the object. So we can see that it outputs 8 on both of these. However, if this was a large application, having this object being passed around various flows, having this be updated in this way can lead to a lot of confusion to how did this actually get changed. So some of the patterns that are available with ES6 and TypeScript is, for example, using the object.assign. This is handy for shallow objects where your properties in this object are not other objects. So in this case, if you want to try and have a bit of an idea of what we're going for, we can use object.assign, where we pass in a empty object, movie 1, and then also the new information that we want to merge onto it. In this case, we can now see that movie 1 has not been modified, and then movie 2 has been changed. However, in more complex applications, trying to enforce immutability through that style of syntax can be a bit messy and cumbersome. So we like to use ImmutableJS, which provides immutable data structures for JavaScript, such as map, list, and others, and also has a number of functions for being able to do deep updates inside of your data without mutations to the original data. So for map and list, it is the immutable version of the JavaScript object and the JavaScript array. They have operations like set and set in, which will return a new instance of the data, not a copy, not a reference to it. And it helps enforce immutability by not providing direct access to the data structure. For example, you can't just go in and do movie.name equals a new name without kind of going through their proper methods. So I'm going to pull up a quick example here where we can walk through how this actually works out. So with this example here, let's go. And so with this example here, we basically have a immutable list that is an immutable object that is using from.js. The reason why we use from.js instead of say immutable.list is this will ensure that the entire structure is a immutable object. If we had just done immutable.list, it would be an immutable array, but the internal objects would be mutable. So for example here, movie is not an actual object because this is now a list. We have to use movies.get0 to actually get the item that we want. And since this the internal object is now a immutable object, we can't just do movie.name or we'll get undefined. We have to use movie1.getName. And if we want to update the movie name, we have to use the set and to update the name. And with this, the initial movies collection will not be changed. Why this is important is, especially if we're using the on push, this will help ensure that a new object is always being passed around and have the change detection work correctly. Also, for kind of getting and updating data within the array is that you can also use getIn and setIn, which will provide a path to the data that you want to get out. This can, and these methods can also understand like a deeply nested structure. So, for example, here we have a update movies.getIn1 name. What this does is you pass in an array where you can specify either a number if you're using a list. So this is the index in the array, and then name is the property that you want to have. This can understand a deeply nested structure, so you can form this up fairly dynamically. And you can also use this to update properties within, and then when you're doing updates with a setIn, likewise, you can provide a setIn and what is called a key path, and as a result of that setIn, you'll kind of get an entirely new object out, not just the one object that you updated. Let's get that. Yeah. So now that we've covered immutability in Angular 2 a little bit, we're going to move back onto Varun, who will discuss forms.
So forms are still similar to Angular 1, one of the most powerful features that Angular provides us. In Angular 2, there are a few different ways that we can create forms. So we can use the form directives to do that. We can use the control group, and the control array classes that are new in Angular 2. And we can also use the form builder class. So today, I'm just going to be focusing on the form builder class. So form builder is essentially a class that allows us to create a form programmatically. So let's look at an example of how you would use a form builder. So you start off by importing control group from Angular 2, and control group is just the output that a form builder gives you. So we need that to assign the control group type to this internal group that we're creating within this form component. The next thing we need to do is actually inject form builder into our component, and we're using the simplified DI syntax here, so builder : form builder, and once we do that, builder is available to us within this constructor, and we can go and create a new form group. And in order to create a new form group, we call the group method on the form builder, and this group method accepts an object, and this object is the definition of your form. So each property of the object is essentially a field on the form that you're trying to generate. And to instantiate this field, you pass in an array. The first value of that array is the default value that you want to set for this field. In our case, I'm going to leave that as an empty string, so we're not actually going to set a default value. And once we have this group set up, it's available as this.group. So within this component, we have this property called group that's available for us to use in our template. So let's switch over to the template. Now, in order to connect the group that we've just defined to HTML, we start by using the ngForm model directive. Again, we use the square bracket syntax to actually use data binding to bind group to HTML. And then in order to attach each individual field back to this group, we have to use the ngForm control directive. And again, we're using the data binding syntax here. The only difference here is instead of just assigning it to something that's defined in our component, we actually have to go and get the field from within the form group that we've just created. And the way we can do that is by using the .find method that's available to us in our form builder. So if we do a group.find and pass in an argument, which is the string name for the field that we're trying to get, this will return the email field to us, and then we bind it to our input field. And we do the same thing for password. Now you'll also notice that there is an ngModel directive that we've used here. And the reason why we've done that is in order to edit something, edit an existing value. So even though we have ngModel attached to our input field, if we switch back to our component, you'll notice that we haven't actually defined this user model in here. So let's look at what this model looks like. So models in Angular 2 are just plain JavaScript classes, no decorators attached to them. And in our case, the user model is a very simple model where you have two properties, email and password, and both are of type string. So we start by creating a user property in our form component, and then in the constructor, we'll simply create a new instance of this user and pass in the values that we actually want to set this model to. So now we have this.user available to us within our form. And if we have ngModel applied to input fields, now these fields will actually be attached to the value that's coming in from the user object that we have in our component. The other exciting part about forms in Angular is validation, and just like Angular 1.x, Angular 2 has a lot of built-in validations. And the way you set validations on a field is by adding a second item to the list in the field definition. So previously we had email equals an array with just an empty string, and now we're adding a second item to it, which consists of validators.compose. So validators is a class in Angular, and it has a compose method that allows us to compose multiple validation criteria. So here we're just trying to set email to be required. In case of password, we're setting it to be required, but then also we require a minimum length of 4 characters. And then in order to check for validation in our template, we can do things like group.find to get the field, and then check for for properties like dirty, valid, touched that we had available in Angular 1, same thing in Angular 2. And to see if we actually have an error that's set to be true. So in case of our input username field, if the user hasn't actually entered anything into that field, to figure out if that error is actually true or false, there's another method that's available to us on this form builder group. So that's called hasError. So we call group.hasError, and then the first argument is the type of error that you're checking for, and the second argument is the field that you're checking for. So to check to see if a field is required and the user hasn't set it, we call group.hasError required email, and then we can do the same thing for a password. To check for min length, we pass in min length as the first argument. Now, of course, apart from built-in validations, there's also custom validations. And to create a custom validator, what you do is start by creating a class called custom validators. And then you set a static method on this class, which is going to be the type of validation that you're checking for. So in our case, we're checking for email format. So we define a method called email format. And then this method simply returns either null to us, and we return null when validation has passed successfully. But if the validation has failed, we return an object which tells us what kind of validation failed. So in our case, we need to tell Angular that email format failed, so we set email format to true. And then to use them, you can just simply inject the custom validator method into your validator's compose call. So along with synchronous custom validations, you can also build out asynchronous validations, very much like Angular 1. So in Angular 1, for asynchronous validations, you return a promise instead of null or an object. In Angular 2, you do exactly the same thing. So you start off by defining the method that is the validation. In our case, we're calling this duplicated. And then what we're trying to replicate here is the idea of checking to see if a username is already being taken or if it's available. And we're going to simulate that by using a set timeout. And then we're using the ES6 syntax for promises and returning that promise out of this validation method. And now, after completing our validation, we either resolve with null to tell Angular that this validation has successfully passed, or resolve with an object which tells us what kind of error has been set to true. Now, to use an asynchronous validation is slightly different. Instead of using just simply the compose method as the second item in our definition. We're actually going to use a third item, and the third item is the asynchronous validations that we can pass in. And then lastly, we still have all the CSS classes available to us to provide visual cues. So each field gets applied with classes like ngPristine, dirty, touch, etc. So that's everything that we had to share today. Thank you all for joining us. I know we're running a little bit over time here, but we're still going to stick around to answer some questions. So feel free to type them in. And if you have to leave, we have our Twitter handles up here, so feel free to reach out to us after to ask any more questions you have. So starting with the first question, is this the same event emitter from Node? Short answer, no. The event emitter is just a wrapper around the RxJS observable, and I believe Angular 2 plans to deprecate it and just simply switch to using the observable. But for now, it's called event emitter. Name on change was just a typo. It just had to be. It was just supposed to be called on change.
It's an interesting question about third-party plugins and would it be a good idea to set them up as injectables? And right now it's looking like that might actually be the case. And adding them as a dependency, yeah, that would probably be the best way to get them in. I think that's how the Angular 2 team is planning on doing it.
And then do you want to answer the next question?
Oh, and then a follow-up is how would a third-party plugin implementation work? Well, essentially, you would write your TypeScript or your ES6 as normal and mark them up as injectable, and then provide them and provide the minified output, like is common in normal modules these days. Typically, this is done through npm modules, is what we've been working with for the most part, and they're importable directly into TypeScript and Babel, and then you would just inject them into your bootstrapping part. That's pretty much it, I think.
Okay, and then we have a question about routing here.
Yeah, so the question is, do you need to define all routes per component for instance A and B? Both those routes use ABC. Do you need to define it in each component? So I guess in this scenario, if you have a route, the root component, if you have, like, say, in your parent component a route called ABC, you would not need to define that individually in A and in B. When you're using the router link definition, you would then, if you want to navigate to ABC, you would then have /ABC, and that is what would tell Angular that it wants to find this route within the parent and not within your current component.
Strongly typed views, that's interesting. I mean,
Don't just repeat the question.
Oh, sorry. The question is actually, is there any way to create strongly typed views within Angular 2? And using plain strings can cause typos and application crashes. I know in terms of the actual typing system, you can use types within TypeScript, but they're not technically strong types in that context. But I think this question is actually more about the templating. Is that what your read is?
Yeah. Yeah, and I don't believe that there is a way that you have a strongly typed template that I'm aware of yet. Since the template is pulled out into the @ component and not within the class itself, unfortunately, there isn't a way yet to have a strongly typed template that I'm aware of.
So there's another question asking whether it's better to use TypeScript instead of ES6 with Angular 2.
To that point, I think it's a lot easier at this stage to use TypeScript. It seems like it would be easier to use ES5, especially for people who are older school individuals like myself, but in diving into Angular 2, I've just had a much easier time with TypeScript. The module system everything every piece of information you can find is oriented around TypeScript right now. And there is some work people have done to illustrate how to use things in ES5. And I mean, it can definitely be done in ES5. Everything gets transpiled to ES5, but I've actually just been able to write things a lot faster by working with the TypeScript versions of things in Webpack than I have been. I mean, ES5, I just banging my head against a wall a lot of times, even though it's definitely doable.
So this question is it possible to prevent a route from being activated when the user navigates back to it, for example, using the browser back button, for instance? That's one thing that I didn't get a chance to cover in the routing yet, but there are some routing life cycle hooks. One is called can activate, and the other one is can deactivate. So you could use those to hook into the browser events, and then what Angular will do is if it sees these hooks on that component, you can use the can activate or can deactivate to prevent things from happening. So one case is, say, preventing a backwards navigation. The other case would be, let's say you're on a form and it's dirty, and you want to prompt the user, are you sure that you want to navigate away? So I think it would be possible to prevent the routes being activated using those hooks.
So there's a question here about CSS frameworks and whether there are any CSS frameworks out there that are compatible with Angular 2. The short answer is pretty much every CSS framework is compatible with Angular 2. However, if you're trying to use the JavaScript parts of that framework. So, for example, if you're trying to use like modals from Bootstrap, previously there was the Angular UI project that had kind of ported that over to Angular 1.x. I don't believe there is anything out for Angular 2 yet. Ionic is working on Ionic 2, which is built out with Angular 2. But if you want a purely CSS solution, you can go and use pretty much any framework that you like. We tend to be using base CSS here at Rangle.io.
Yeah, so the next one is how can you configure dynamic routing, for example, user role and entitlement-based systems. If I'm understanding this kind of correctly, this is where you want to perhaps restrict routes like based on a role, and this is where you would hook into like the can activate and can deactivate hooks. So if you have a component where you want to ensure that a person has a specific permission, in the can activate route hook on that component, that is where you'd be doing those checks.
I don't believe so. So the question here is there an Angular 2 component marketplace that's available, either officially from Google or third party? I don't believe so. Again, I'll defer to Ionic here. Ionic does have a marketplace for components that are compatible with Ionic, but for now they're limited to Ionic 1, which is Angular 1.x. But I assume as they're transitioning to Angular 2, there will be more Ionic 2 components in the marketplace. Okay, looks like that was all the questions we had. If there are no more questions, thank you everyone for joining us. This was a very shallow introduction to Angular 2. There's a lot more to cover here, so continue joining us for this webinar series. There's 2 more webinars left in this series. And then also we're offering a more detailed online training for Angular 2. Go to Rangle.io to check out when that's happening and sign up for that training. And thank you for joining us.